A very different kind of light show was on display in Italy. Mount Etna is erupting again.
Mount Etna is erupting, and it seems somebody is behind this to erase humankind. Everyone in Sicily is rushing to escape as lava flows towards their homes. This giant volcano usually just smolders, but now it's spewing fire and danger, lighting up the night sky. The land that feeds them with its rich soil is now a terrifying threat. What monstrous power has woken up Etna this fiercely? Let's find out what's driving this devastating eruption. The unrelenting power of Mount Etna. Mount Etna, located on Sicily's eastern coast, isn't just any mountain. It's a towering volcano that rises up to 10,830 feet. Interestingly, its height changes with each eruption. This constant change makes Etna a key focus for scientific research. But what truly makes Mount Etna unique? Its long history of activity is remarkable. Estimated to have been erupting for over 500,000 years, it predates any known civilization and has erupted many times, often causing serious damage. For instance, in 1669, an eruption destroyed several villages and reached all the way to the city of Catania, reshaping the landscape and even changing the coastline. The volcanic soil around it is incredibly fertile, making it perfect for growing grapes, olives, and other crops. People living near Etna often say, "Etna gives and Etna takes," acknowledging that while the volcano can be dangerous, it also provides vital resources for their way of life. Now, where did Mount Etna come from? This giant volcano stands about 11,014 feet tall and has a history that goes back millions of years. Its formation is closely tied to the movements of the Earth's tectonic plates. Sicily sits at the meeting point of the African and Eurasian plates, huge sections of the Earth's crust whose interactions cause significant geological activity. When the African plate moves under the Eurasian plate, it melts due to the intense heat and pressure. This molten rock, or magma, being lighter than the surrounding solid rock, rises. Over millions of years, this rising magma has erupted through the Earth's surface, spewing lava and gradually building up to form Mount Etna. The ongoing eruptions remind us that nature is always in motion, constantly shaping and reshaping the world we live in. Mount Etna has been active for a very long time, showing just how complex it is. It's not just one big mountain, it's made up of layers of hardened lava, ash, and volcanic rocks from many different eruptions. This Italian volcano has several craters and many vents along its slopes, making it both challenging and fascinating to study. What's special about Mount Etna is how often it erupts. While some volcanoes can stay quiet for years, Etna is almost always active. This is because of the movement of tectonic plates beneath it. When the pressure underground gets too high, Etna releases it through eruptions. These eruptions can be explosive, sending up huge fountains of lava and ash, or they can be gentler, with lava flowing slowly and changing the landscape around it. For scientists, Mount Etna is like a big outdoor lab. They study how magma moves below the surface, how eruptions happen, and what comes after. For example, a recent big eruption sent streams of hot lava and clouds of ash into the air, causing Catania's nearby airport to close temporarily. Watching and studying these events is very important because it helps scientists understand how volcanoes work worldwide and improves the way they predict eruptions. To keep an eye on Etna, they use various tools, including seismographs, satellites, drones, and gas sensors. Let's see how Mount Etna's eruptions have shaped its surrounding area and affected its people. A timeline of destruction. But even with all this technology, it's still hard to predict exactly when Etna will erupt next. Mount Etna has always been both amazing and scary. Its first recorded eruption was around 1500 BC, but it had likely been erupting long before that. Ancient civilizations like the Greeks and Romans saw its power up close. Etna's eruptions have shaped the land and had a big impact on the people living nearby, leaving a lasting mark on history. One of the worst eruptions happened in 122 BC. It hit Catania so hard that the Roman Senate decided not to collect taxes from the city for 10 years to help it recover. Then, in 1669, another huge eruption started with earthquakes, followed by a crack in Etna's side that poured out a river of lava. It destroyed villages as it moved toward Catania. Even though the city walls helped block some of the lava, A lot of damage was already done, and the eruption went on for months, even changing the coastline when the lava reached the sea. In 1928, another powerful eruption wiped out the town of Sicily, covering it with lava and leaving almost nothing behind. This shows that Mount Etna's story is far from over, and it continues to write new chapters of awe and destruction. The Italian authorities didn't just stand by, they built new Sicily town further away from the dangerous reach of Mount Etna. This ongoing cycle of destruction and rebuilding shows how Mount Etna is both a problem and a source of support for the people living nearby. Between 2002 and 2003, Mount Etna had a major eruption with strong explosions and new cracks opening along its sides. This eruption sent large clouds of ash into the sky, which disrupted air travel, and lava flowed dangerously close to nearby towns. Thankfully, scientists were carefully watching the situation using advanced technology. Their early warnings helped keep the local communities safe. When we look at the most recent major event at Mount Etna, which happened on August 4th, 2024, we see that the warning signs started the evening before, on August 3rd. People living near the volcano noticed more frequent earthquakes, which is a usual sign that an eruption might happen. These tremors happen because magma is pushing its way up through the earth, trying to find an exit. The National Institute of Geophysics and Volcanology in Catania was closely monitoring these tremors and quickly informed the public that an eruption was likely. As the night went on, the earthquakes became stronger. By 3:20 a.m., the signs showed that an eruption was certain. Then at 4:40 a.m. on August 4th, Mount Etna erupted, mainly from the Volcanic crater on its southern side. Huge lava fountains shot up to 4,900 feet into the air, and a massive ash cloud rose 10 kilometers into the sky, drifting southeast and covering nearby communities with ash. Imagine waking up to find your town covered in a thick layer of black ash, making it look like a strange, dark, snowy landscape. This is exactly what the residents experienced. The ash, small particles of volcanic rock, landed on homes, cars, and streets. People shared pictures online of what some called black snow. The ash polluted water supplies, ruined crops, and posed health risks to people and animals, especially if breathed in. Local authorities advised everyone to stay indoors as much as possible and to wear masks if they had to go outside. Cleanup teams were quickly organized, working hard to remove the ash from streets and public areas to help things return to normal. Now we focus on how the recent eruption disrupted life and travel around Mount Etna. Mount Etna's fiery challenge. The situation was difficult. The volcanic eruption made it hard for airplanes to fly safely. The INGV, a group that monitors volcanoes, issued an important alert for air travel because volcanic ash can damage airplane engines, making flying more dangerous. On that Friday, the airport in Catania had to close because the runways were covered in ash. As Mount Etna kept spewing lava, flights were either canceled or sent to other airports to avoid the ash cloud. Mount Etna's recent activity showed just how unpredictable it can be, constantly challenging the nearby communities. Thankfully, the airport staff and emergency teams did an excellent job, working hard to remove the ash and ensure the safety of travelers. But the eruption wasn't over yet. Lava kept flowing steadily from the Volcanic crater, moving down Etna's slopes. Luckily, the lava didn't reach major towns, but it did cover farmlands, destroying roads and other structures. Local farmers could only watch as their fields and orchards were buried under the hot lava. The damage to these agricultural areas was a serious hit to the local economy. As time went on, the eruption started to slow down. The volcano's activity dropped to medium-high levels, indicating less magma flow. The number of lava fountains decreased, and the large ash cloud began to clear. Although the immediate danger was lessening, the cleanup was just beginning. The community stayed vigilant, clearing ash and evaluating the damage, especially to the farmlands. Authorities were actively organizing relief efforts for those most affected, with the Civil Protection Department leading safety measures and setting up temporary shelters. The event highlighted Mount Etna's powerful presence, leaving a deep impact on those who experienced it. It was a strong reminder of how nature can disrupt lives and the importance of community strength in facing such challenges. Being Europe's most active volcano, Mount Etna draws a lot of scientific interest. Researchers often visit the site to study its behavior, gaining valuable knowledge that helps manage other volcanoes around the world. Because of its frequent eruptions and closeness to populated areas, Etna is a critical volcano for ongoing study, essential for predicting eruptions and planning for safety. Living near Mount Etna comes with its risks, but understanding its behavior can greatly reduce those risks. Scientists are focused on predicting future eruptions, allowing local authorities to warn residents early and take steps to protect people, homes, roads, and farms. Better knowledge of Etna's patterns leads to better emergency responses and safety measures. Every time Mount Etna becomes active, it turns into an open-air classroom full of fascinating geological features. Scientists study the rocks, lava, and ash that it releases to better understand what's happening beneath the Earth's surface. Their research helps us learn how our planet was formed and how it continues to change over time. This work is vital for understanding how the Earth's plates move, which can improve our ability to predict earthquakes and other geological events. Mount Etna serves as a lively outdoor lab for both new and seasoned geologists. It attracts experts from around the world who are eager to study its complex volcanic activities up close. The experience and knowledge gained here are essential, helping to train the next generation of geologists and volcanologists to deal with similar natural events in other parts of the world. Recent eruptions have given scientists a clearer picture of how magma moves beneath a volcano. By studying seismic readings and the materials that the volcano ejects, they've discovered several magma reservoirs at different depths. The way these reservoirs interact affects how strong the eruptions are and what kind of eruption happens. Understanding these processes is key to making better predictions about when and how the volcano will erupt. Next, we'll explore how scientists use new data to study Mount Etna's unpredictable behavior. Patterns that predict peril. By looking closely at Mount Etna's recent explosive events and its more gentle lava flows, researchers have spotted specific patterns. These patterns help predict the volcano's future behavior, allowing authorities to issue timely warnings to protect people living nearby. The ongoing study of Mount Etna not only deepens our knowledge of how volcanoes work, but also improves safety by enhancing our ability to forecast eruptions. But that's not all. Understanding these patterns could mean the difference between a timely evacuation and a sudden disaster. The insights gained here have far-reaching implications, not just for those near Mount Etna, but for communities living near volcanoes around the world. Recent studies have focused on the gases released by Mount Etna, like sulfur dioxide, carbon dioxide, and water vapor. Monitoring these gases is important not only for understanding the volcano's current state, but also for predicting future eruptions. It's also vital to learn how these gases impact the environment and climate, which is key for broader ecological and atmospheric research. As we look at the latest eruption, we also consider the tools scientists use to predict these events. Observing recent lava flows has given scientists important insights as well. By studying the way lava moves and spreads, researchers can understand the effects of different factors such as the slope of the land and the thickness of the lava. This information is crucial for making accurate hazard maps that help protect communities from the dangers of lava flows. Advances in technology have changed the way we monitor Mount Etna. Today, scientists use a mix of satellite images, drone footage, and sensors on the ground to get a complete view of the volcano's activity in real time. These tools provide detailed data on everything from tiny ground movements to changes in gas emissions, greatly improving our ability to monitor and respond to potential threats. Mount Etna's ongoing activity fascinates scientists all over the world and promotes global teamwork. This international cooperation is essential for deepening our understanding of volcanic behavior and improving the models used to forecast eruptions. By sharing knowledge and technology, everyone involved in studying volcanoes and managing risk benefits. While predicting exactly when and how Mount Etna will erupt remains challenging, continuous research and technological advances have significantly improved our ability to forecast eruptions. By studying past eruptions and keeping a close watch on current conditions, scientists can spot early warning signs of an eruption, like increased seismic activity, noticeable changes in the landscape, and shifts in gas emissions. One of the main ways to predict eruptions is by monitoring seismic activity. Seismographs placed around Mount Etna record and analyze the tremors that signal magma moving beneath the surface. By examining these seismic patterns, experts can better predict when an eruption might happen. Tracking how the ground moves is an important way for scientists to keep an eye on volcanoes. As lava pushes closer to the Earth's surface, it causes the land to swell and crack. Scientists use GPS and satellites to carefully watch these movements. By doing this, they can figure out how much lava is building up and guess where it might erupt. Another crucial part of monitoring volcanoes is checking for gas emissions. As lava rises, it releases gases. If these gases start to increase, it might be a sign that an eruption is coming soon. Scientists constantly monitor these gases to predict when and how Mount Etna might erupt. Satellites are very helpful in observing Mount Etna. They are equipped with special tools to detect heat and changes in the landscape. This allows scientists to get a full picture of the volcano's condition, even in places that are hard to reach. This satellite data is essential for keeping track of ongoing eruptions and predicting future volcanic activity. Moving forward, we'll look at how drones are changing the way we study and monitor volcanoes like Etna. Drones at the heart of volcanic surveillance. The development of drone technology has greatly improved how we monitor and study active volcanoes like Etna. With drones, scientists can safely reach dangerous or remote areas that would otherwise be inaccessible. These drones come equipped with high-resolution cameras and advanced sensors that can gather various types of data. This data includes measuring the composition of gases, tracking ground movements, and even creating detailed 3D maps of the landscape. One of the main advantages of using drones for volcanic monitoring is their ability to take close-up measurements of hard-to-reach volcanoes. This has been especially important for studying volcanoes like Manam in Papua New Guinea, which is a major source of sulfur dioxide emissions. By analyzing the gases that these volcanoes release, scientists can predict possible eruptions and understand how these emissions impact the global carbon cycle. NASA, in partnership with various technology companies and institutions, has been a leader in combining drone technology with other data sources, such as satellite images, to monitor volcanic activity comprehensively. These efforts have included sending drones to capture visual and thermal images that help detect physical changes in volcanoes, which might signal an upcoming eruption. The combination of these technologies not only improves the accuracy of volcanic monitoring, but also helps in disaster preparedness. This allows for timely evacuations and reduces the economic damage caused by eruptions. Additionally, ongoing advancements are focused on making these drones more autonomous, so they can handle complex flight paths and environmental challenges on their own, making volcanic monitoring even more efficient. These technological advances mark a significant change in how we study and manage geological events. They offer the promise of even better safety measures and more effective responses to natural disasters. However, understanding how the ground shifts and tracking gas levels are just parts of the story. Scientists are also constantly looking for other signs that might signal a more serious eruption, and that's where their work becomes even more critical. From the shaking ground and changing landscapes to the release of gases and the information gathered by satellites and drones, all of this data is analyzed using advanced computers. These computers create simulations that show how magma moves inside the volcano, which can lead to explosive eruptions. By combining live data with these computer models, experts can better predict when Mount Etna might erupt again. This research is also crucial for keeping people safe. The information collected from watching Mount Etna is vital for warning local authorities and the community about possible dangers. Systems are in place to give early warnings and emergency plans so that residents can evacuate quickly if an eruption seems likely. Scientists are constantly studying Mount Etna, always looking for new ways to improve their predictions. With better monitoring tools, improved data analysis, and more detailed models, they can better understand how the volcano behaves. These advancements are important not only for making more accurate eruption forecasts, but also for increasing the safety of those living near such a potentially dangerous natural force. However, predicting the behavior of a volcano like Mount Etna is still a challenge. Despite all the technology and knowledge, the volcano's activity can be unpredictable, and there's always an element of uncertainty. Do you think it's possible for science to ever fully predict a volcanic eruption? Comment your thoughts below, and don't forget to subscribe for more discussions.